Every Thanksgiving, more than 46 million turkeys are eaten across the United States, according to the U.S. Department of Agriculture. That's more birds consumed in one day than any other time of the year. But behind every golden roast lies one of America's most complex food operations. From hatcheries to freezer trucks, each turkey's journey takes months of planning and precision. How can factories raise, process, and deliver tens of millions of birds, all in time for a single meal? Today, Captain Discovery steps inside the modern turkey industry to uncover how Thanksgiving really comes together. The wild turkey is native to North America. Long before European settlers arrived, indigenous tribes hunted and domesticated them for food and feathers. In 1621, during the first Thanksgiving in Plymouth, wild turkey is believed to have been part of the feast. By the 20th century, turkey farming became industrialized, transforming a seasonal hunt into a nationwide tradition. Today, Thanksgiving and turkey are inseparable, a symbol of abundance, family, and gratitude that evolved from ancient forests to modern factories, where tradition now meets technology to serve one of America's most iconic meals. The journey begins in hatcheries, where millions of eggs are incubated under precise control. Each egg sits inside a rotating tray that mimics the natural turning done by a mother bird. Once hatched, they move to warm brood houses with soft bedding and red lighting that encourages feeding. Automated feeders deliver protein-rich mash made from corn, soybeans, and vitamins. Each is equipped with fans, misting systems, and climate control to keep humidity steady. Every turkey raised today is part of a massive data-driven system built to supply one national holiday. A modern turkey grows fast, from hatchling to 40 pounds in just 5 months. Feed mills grind corn and soy into fine powder, then mix in minerals, amino acids, and probiotics. Automatic dispensers spread feed along metal lines, while water runs through nipple drinkers that prevent waste. Most barns stay around 70 degrees Fahrenheit, mimicking mild autumn days. Healthy growth means fewer antibiotics and better meat texture. By the time Thanksgiving approaches, these birds have tripled their muscle mass, their feathers thick and bright white, ready for the next stage of their journey. Processing begins early in the morning inside refrigerated facilities where the air rarely rises above 45 degrees Fahrenheit. Turkeys are transported in ventilated crates and stunned humanely using controlled electric current. It renders them unconscious in seconds, a standard approved by the American Humane Association. After stunning, automatic lines lift the birds onto stainless steel conveyors. Feather removal machines use rotating rubber fingers and jets of hot water to loosen and strip the feathers. Each carcass is then washed with chilled water to remove any residue before entering the evisceration area. Workers inspect every bird by hand, while scanners detect internal defects invisible to the eye. Organs are separated, edible ones saved for giblets. The rest are processed into byproducts like pet food and stock bases. Would you still enjoy turkey if you saw what happens here? Once cleaned, turkeys enter the marination area. Here, giant tumblers rotate hundreds of birds at a time while brine, a mix of water, salt, sugar, and spices, flows through fine nozzles. Some turkeys are prepared for convenience packaging. Each unit is vacuum sealed to lock in freshness. Sensors scan for metal fragments or air pockets in the seal. Packages that fail inspection are automatically diverted for reprocessing. By the end of this step, the birds look like the ones you see in supermarket freezers: clean, smooth, and oven-ready. In the final stage, conveyor belts move turkeys toward packaging lines chilled to 33 degrees Fahrenheit. Some are wrapped whole in heat-shrinking film. Others are portioned into breasts, legs, or ground meat. Machines print labels with batch numbers, weights, and use-by dates. Every pallet passes through a metal detector and a barcode scanner for traceability. From there, forklifts load boxes into refrigerated trucks bound for distribution centers. Most shipments leave weeks before Thanksgiving. The turkey might be the star of the table. But before the feast even begins, something sweet and warm fills the air. It happens every morning. That glowing red sign that says, "Hot now." According to Statista, Krispy Kreme sells over 1.3 billion donuts each year across more than 30 countries. People line up before sunrise for something that vanishes in one bite. But inside the factory, that perfect softness comes from a process that's anything but simple. Mixers spin, fryers hiss, and a waterfall of sugar glaze runs like liquid glass. How does one 1937 recipe still create the melt-in-your-mouth donut that millions crave? Today, Captain Discovery steps behind the glass to find out how it's really made. Krispy Kreme began in 1937 in Winston-Salem, North Carolina, when Vernon Rudolph bought a secret yeast dough recipe from a New Orleans chef. He started selling donuts through a small window on the sidewalk. Still warm, still glowing. The aroma drew crowds instantly. By the 1950s, Krispy Kreme had become a Southern favorite. Automation followed in the 1960s, spreading the brand nationwide. Through decades of change, its formula, a delicate balance of yeast, sugar, and air, has stayed almost untouched. Today, it's a blend of nostalgia and precision engineering, one bite at a time. The process begins in industrial mixers taller than an average person. Each batch combines nearly 600 pounds of flour with sugar, yeast, milk powder, and shortening. Water at 86 degrees. Fahrenheit activates the yeast, and paddles churn the mix into a smooth, elastic dough. Once mixed, the dough rests for 10 minutes in covered troughs to relax the gluten. Then it moves through a sheeter that flattens it to exactly 0.4 inches thick. Cutting machines stamp out perfect rings and holes at lightning speed, over 3,000 donuts per minute. Scraps are recycled back into the mixer, nothing wasted. It's the first step in turning simple ingredients into something millions recognize by smell alone. The raw rings travel on conveyors into a long chamber called the proof box, a warm, humid tunnel that simulates rising dough at home. Inside, the air stays steady at 95 degrees Fahrenheit with 60% humidity. Here, yeast cells feed on sugar and release carbon dioxide, puffing each donut until it doubles in size. The process takes about 45 minutes. Employees inspect the trays through glass windows, ensuring each ring lifts evenly. They're ready for what comes next, a bath in liquid gold. Rows of proofed donuts roll down a stainless steel ramp into oil heated to 350 degrees Fahrenheit. They float automatically, one side frying for 40 seconds before a mechanical arm flips them over. The sight is hypnotic. Hundreds of golden rings bubbling in perfect unison. After frying, they rise from the oil onto a moving rack, glistening. Do you prefer your donuts glazed or filled? Let us know in the comments. We're curious which one wins. This is the moment Krispy Kreme is famous for. The freshly fried donuts move under a wide metal curtain where liquid glaze, a simple mix of sugar, milk, and vanilla, pours endlessly in a shimmering sheet. Each ring passes through the glaze in less than 2 seconds, emerging with a perfect, even coating. The glaze itself is held at 120 degrees Fahrenheit to stay smooth. Pumps recirculate it constantly so it never crystallizes. Cooled fans solidify the coating within moments, creating that paper-thin shell that cracks slightly when bitten. In filled varieties, injectors pierce the side of each donut and pump in cream or jelly with precision down to the gram. Every piece is weighed again before moving to the packaging line. Uniform, shiny, and irresistible. Once glazed, donuts travel on belts through cooling tunnels at 60 degrees Fahrenheit. They line up in neat rows and slide into boxes printed with the familiar green dots. Machines seal and stack the boxes, while conveyors move them to loading docks. Trucks with temperature control deliver boxes nationwide within hours of production. From factory to hand, a donut's lifespan is short, only a day or two before it goes stale. Donuts may sweeten the start of the day, but Thanksgiving dinner isn't complete without something red, tart, and perfectly smooth. And for that, we head north, to the cranberry fields. That soft pop, when a can of cranberry sauce opens has echoed through American kitchens for generations. It's more than a side dish, it's a memory. According to Ocean Spray, Americans consume over 80 million pounds of cranberries every Thanksgiving season. For many, that red jelly on the plate means family, warmth, and the start of the holiday meal. But few know what it takes to transform a wild berry from cold marshes into that smooth, ruby-colored jelly we all recognize. Today, Captain Discovery heads to the bogs and factories where Thanksgiving's brightest color is born. Cranberries are one of North America's few native fruits. Long before settlers arrived, native tribes used them for food, dye, and medicine, often mixed with dried meat and fat to make pemmican. European colonists adopted the berry in sauces and preserves. By the 19th century, cranberry farming stretched across New England. In 1930, the Ocean Spray Cooperative transformed the crop into a commercial success, creating juices and canned sauce that defined the modern Thanksgiving table. Since then, the cranberry has remained a symbol of homegrown tradition, tart, bright, and unmistakably American. Cranberries grow on low vines in sandy bogs, not on trees. Each autumn, farmers flood these fields with up to 18 inches of water, turning acres of land into shallow lakes. Mechanical reels, called egg beaters, churn through the bogs, shaking ripe berries loose from their vines. Air pockets inside the fruit make them float to the surface, where they form a red carpet across the water. Workers in waterproof suits guide floating booms to corral the berries. Pumps then lift the fruit into trucks, sending up a spray of crimson water. A single bog can yield 200 barrels per acre, each barrel weighing about 100 pounds. It's one of the few harvests that looks more like art than agriculture, a field of color ready for Thanksgiving. At the factory, trucks unload cranberries into massive receiving pools. Here, cold water washes away leaves, stems, and mud. A conveyor lifts the fruit onto vibrating screens that shake off debris. Optical scanners flash light at every berry to detect color and size. Green or damaged fruit is blown aside with bursts of air. Only deep red berries continue down the line. Technicians monitor the flow constantly. Even a small amount of unripe fruit can affect flavor and pectin levels. By the end of this stage, thousands of pounds of bright, clean cranberries roll toward stainless steel kettles. Each one now ready to burst, literally, in the next step. The sorted cranberries fall into steam-jacketed kettles that heat up to 210 degrees Fahrenheit. As they cook, the berries pop, releasing juice and natural pectin, the compound that gives cranberry sauce its familiar jiggle. Sugar is added slowly, dissolving into a syrup that balances the berries' sharp acidity. Some batches include additional fruit pectin or gelatin to achieve that perfect, sliceable firmness. Each batch cooks for about 15 minutes, then moves through filters to remove seeds and skins. Do you eat it fresh or straight from the can? Tell us below. This might settle a Thanksgiving debate. Once the sauce reaches the ideal thickness, it's pumped through stainless steel pipes into filling machines. Metal cans glide beneath nozzles that dispense precise portions, usually 14 ounces per can. The sauce is still near boiling, ensuring sterilization. Lids seal immediately after filling, and cans move into steam tunnels for pasteurization. Inside, heat and pressure stabilize the product, giving it a shelf life of up to 2 years without preservatives. Labeling happens right after cooling. Each can printed with batch codes for traceability. Cans exit the pasteurizer and roll into long cooling tunnels. Robotic arms stack finished cans into cartons of 24, which are shrink-wrapped and loaded onto pallets. Forklifts move them into chilled warehouses, waiting for trucks bound for grocery stores nationwide. And somewhere in those cans sits the same sound everyone waits for. That gentle pop before dinner begins. Sweet, tart, and a little nostalgic. But no Thanksgiving meal ends without something baked, buttery, and full of nuts. Let's head to the pie factory. You can smell it before you see it. That mix of butter, syrup, and roasted pecans that defines Thanksgiving dessert. According to the American Pie Council, more than 100 million pecan pies are enjoyed every year in the United States. Each slice looks homemade, but most are baked by machines working around the clock. Inside modern bakeries, flour, syrup, and nuts come together in a process as technical as any factory line. How do they capture the flavor of a kitchen-baked pie at industrial scale? Today, Captain Discovery steps inside America's pie factories to see how sweetness meets precision. Pecan pie traces its roots to the American South, where pecan trees grow naturally along the Mississippi River. Native tribes prized the nuts for their rich oils long before European settlers arrived. By the late 1800s, cookbooks began listing pecan pie recipes using corn syrup, a new sweetener from the Midwest. The dessert rose to fame during the 1930s when Caro syrup printed its own version on bottle labels, turning it into a national favorite. Today, it's more than dessert. It's a symbol of Southern comfort and one of the few holiday dishes unchanged for generations. It all begins with the crust, the foundation of every pie. Industrial mixers combine flour, shortening, salt, and chilled water in batches weighing up to 400 pounds. Temperature is critical. If the dough gets too warm, the crust becomes dense. Once mixed, the dough moves through rollers that flatten it to uniform thickness. Robotic cutters stamp out perfect circles that drop into aluminum pie tins. Press molds shape the edges into the familiar scalloped patterns seen in homemade pies. Technicians check moisture and elasticity constantly, ensuring the dough remains flaky after baking. Each shell then travels through a short freeze tunnel, locking in shape before filling. From here, it's all about what goes inside. In massive stainless steel tanks, a mixture of corn syrup, brown sugar, eggs, butter, and vanilla is blended at 120 degrees Fahrenheit. The syrup provides sweetness, but also structure, creating that gooey layer beneath the pecans. Industrial paddles stir continuously to prevent air bubbles and separation. Liquid eggs arrive in sealed bags, already pasteurized. They're poured in through controlled pumps, maintaining exact ratios down to the ounce. Finally, chopped pecans are added, sometimes roasted beforehand to enhance aroma. The mixture thickens slightly as it cools, ready to flow into hundreds of waiting pie shells. Conveyor belts carry rows of pie shells under automated nozzles that pour the filling in smooth spirals. Each nozzle stops at precisely the same level, controlled by weight sensors. Whole pecans are then dropped on top by robotic dispensers, arranged in perfect concentric circles. Workers inspect random pies for even distribution and edge integrity. Cameras mounted above the line detect imperfections in shape or gloss and remove defective ones automatically. Once decorated, the pies head straight into one of the most carefully timed ovens in the food industry. Rows of unbaked pies enter continuous tunnel ovens, stretching over 100 feet long. Inside, heat gradually increases from 325 degrees Fahrenheit to 375 degrees Fahrenheit, ensuring the filling sets without burning the crust. As the syrup thickens, the surface bubbles and caramelizes. The smell of roasted pecans and butter fills the entire plant. Once the crust turns golden and the filling firms up, the pies roll out to cool on metal racks. If this smell could reach you right now, would you still bake your own or grab one of these instead? Tell us below. After baking, pies move into cooling tunnels where filtered air keeps temperature below 80 degrees Fahrenheit. Automated lifters transfer them into packaging stations, where each pie slides into a clear plastic dome. From there, refrigerated trucks carry them to grocery stores nationwide. Most pies are baked just days before Thanksgiving, a short window that ensures freshness for holiday shelves. By the time they reach dinner tables, the crust is crisp, the filling glossy, and the nuts perfectly toasted. Each one looks like it came straight out of Grandma's oven, only made by the thousands. From the turkey farms to the donut lines, from cranberry bogs to the pie ovens, every part of Thanksgiving is a story of timing, craft, and care. What we see on the table in a single afternoon often begins months earlier in factories and fields across the country. Behind each flavor are people you'll never meet: farmers waking before dawn, engineers keeping machines in rhythm, and workers whose hands shape the food that brings families together. Thanksgiving isn't just about eating. It's about connection, the long, invisible chain that turns nature into comfort. Every drumstick, every donut, every crimson slice and golden crust carries a trace of human effort and precision. And yet, in the end, all of it becomes something simple: a moment shared. So next time you sit down to dinner, maybe look at the table a little differently. Every plate is proof of how far we go to preserve tradition, taste, and togetherness. What dish means the most to you this time of year? Tell us in the comments. We'd love to know. And if you want to see how other everyday foods come to life, subscribe to Captain Discovery and join us on the next adventure inside the factory floor.